Dear students, welcome to the session C6 of first PUC chemistry. So in the last class I have started the first chapter in your chemistry, namely some basic concepts in chemistry. So in basic concepts I told you what is chemistry, what are the branches in chemistry, what is the significance of chemistry, and later on classification of the universe. The whole universe is divided into two classes, namely matter and energy. Energy is a non-matter or non-material. So again the matter is classified under two categories, namely physical classification and chemical classification. So matter is classified into two types, physical classification and chemical classification. So in physical classification, based on the physical states of the matter and the properties, they are classified into three types, namely solids, liquids and gases. So in the last class I told you what are solids, liquids and gases. Solids are the substances which have definite volume and definite shape. They have, here the particles are very closely packed. The position of the particles is fixed, therefore they have definite shape. So you know examples: solids, all metals except mercury, sugar is a solid, iron is a solid, rubber is a solid, etc. Coming to another class of substances, liquids. Liquids are the substances which have definite volume but do not have definite shape, because here the molecules are closely packed but the position of the molecules is not fixed. Molecules can move freely from one place to another place within the boundary of the liquids. Therefore, they will have the shape of the container. Examples for liquids: water, oils, milk, kerosene oil, etc. liquids. Coming to gases. Gases are the substances which do not have definite volume and definite shape. Particles are very far away from each other. There is no force of attraction between the molecules. Molecules can move freely from one place to another place. Therefore, they don't have any shape and don't have any definite volume, but they will occupy the entire space of the container or the room. So today we will come to the chemical classification. So classification of matters on the basis of their chemical properties. Under chemical classification, matters are mainly classified into two types: pure substances and mixtures. Pure substances are again classified into two types: elements and compounds. So what are elements? Again, elements are classified into three types based on their properties and their physical states: metals, non-metals and metalloids. All these things you have written in the last class. Again, these compounds are classified into two types: organic compounds and inorganic compounds. And then in mixtures, again there are two types: homogeneous mixture and heterogeneous mixture. So first we will study chemical classification. Write down: chemical classification of matters. Chemical classification of matter. Okay. So you please keep a separate notebook from chapter 1. You go on writing. So whenever I tell you it is important, you make a star mark on that questions, and those questions will be asked in your examinations. So today your note starts from chemical classification of matters. So here, write down here, matter is again classified into two types. So under chemical classification, matter is again classified into two types. Number one, pure substances, and number two, mixtures, mixtures, mixtures. First we will know what is a pure substance. Pure substance. For example, so you have seen your common salt which is used in your kitchen. Common salt. What is the chemical name of common salt? Common salt. Its chemical name is sodium chloride. Sodium chloride. So what is its formula? NaCl. So you know sodium chloride. Baking powder. Baking powder. What is its chemical name? Sodium bicarbonate. This is baking powder. Washing soda, Na2CO3, sodium carbonate. Similarly, sugar, cane sugar, C12H22O11. So similarly, you know gold. Gold, what is its formula? Au. Silver, Ag. Iron, Fe, etc. These are all some of the examples of pure compounds. You have seen sugar, you have seen sodium chloride, you have seen sodium carbonate, sodium bicarbonate. Sodium bicarbonate is baking soda. Washing soda, sodium carbonate. Iron piece you have seen, gold you have seen, silver you have seen. All these substances are called pure substances. Then what is a pure substance? It is a material consisting of only one type of substances. Material consisting of only one type of substance is known as a pure substance. Write down pure substance. Material containing only one type of substance. Only one type of substance is called a pure substance. Is called a pure substance. Material containing only one type of substance is called a pure substance. So in pure substance, again there are two types, metals and compounds. Metals and compounds. Write down in pure substance. Pure substance. Pure substances are again classified into two types, namely VIZ, elements elements, and number 2 compounds, elements and compounds. So material containing only one type of substances is called pure substance. Pure substances are again classified into two types, namely elements and compounds. What are elements? For example, gold is an element, iron is an element, hydrogen is an element, oxygen is an element, etc. So what is an element? An element is a pure substance containing only one type of atoms. Only one type of atoms. Write down. An element is a pure substance. An element is a pure substance containing only one type of atoms. Only one type of atoms. So elements are of three types. Elements are of three types in bracket based on their physical state. Based on their physical state and properties. They are metals. Number 1, metals. Number 2, non-metals. And number 3, metalloids. Metals, non-metals and metalloids. So examples for metals. Examples for metals, namely sodium, its formula is Na. Gold, its formula is Au, silver, its formula is Ag, etc. And number 2, non-metals. Non-metals, example hydrogen, its formula is H2, oxygen, its formula is O2, chlorine, its formula is Cl2, etc. It's Cl2, etc. And coming to metalloids. So all these things we will discuss in detail later on. So example 3, metalloids. Example, boron, capital B, silicon, Si, silicon. Fourth one, arsenic, As, tellurium, Te, etc. are metalloids. So what are elements? I told you elements are the pure substances. Elements are the pure substances which have similar kinds of atoms. So this is the periodic table. Elements are arranged in the periodic table in the increasing order of their atomic number. What is atomic number? Atomic number is equal to the number of protons, or it is also equal to the number of electrons present in one atom of an element. So as I have told you, what is an element? An element is a pure substance consisting of only one type of atoms. So we have determined either there are about 120 elements. Some of the elements are present naturally on the earth and some elements are prepared artificially in the laboratory. So these elements are classified into three types. Number one, metals, non-metals and metalloids. So metals are placed in the left of the periodic table. So this is the left side of the periodic table and this is the right side of the periodic table. So metals are placed towards left of the periodic table except hydrogen. So hydrogen is placed in number 1. It can also be placed in number 2. We will discuss why it is placed here and why not in 17th group, etc. in detail later on. So these are the metals, namely lithium, beryllium, sodium, magnesium, etc. All these are metals which are placed in the left side of the periodic table, and the metals which are placed on the right side, namely carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, beryllium, bromium, iron, etc. all are non-metals including noble gases. So in between metals and non-metals there are some elements, namely beryllium, silicon, arsenic, tellurium, astatine, etc. These elements have the properties of both metals as well as non-metals and they are called metalloids. So there is a demarcation between metals and non-metals and these are the metalloids: boron, silicon, arsenic, tellurium, astatine, etc. all are metalloids. Metals are placed in the left side, non-metals are placed in the right side of the periodic table, and metalloids are placed in between metals and non-metals. So we will discuss the properties of these metals later on. So now, what we were discussing: pure substance and mixtures. Chemical classification. In chemical classification, we classified the matters into two types: pure substances and mixtures. Pure substances. What is a pure substance? Material consisting of only one type of substances. So the components of the pure substances cannot be separated by physical methods and they will have a definite composition. I will tell you the difference between pure substance and mixtures later on. Again, pure substances are classified into two types: elements and compounds. What are elements? An element is a pure substance containing only one type of atoms. Elements are again three types: metals, non-metals and metalloids. So metals based on their physical state and chemical properties. So now coming to another type of pure substance, namely compounds. What are compounds? Compounds are the pure substances. Compounds are the pure substances containing different atoms or different atoms or elements. Compounds are the pure substances containing different atoms or elements, combined together in a definite proportion by mass. Compounds are the pure substances containing compounds are the pure substances containing different atoms or elements combined together in a definite proportion by mass. Stop. The components of pure substances can be separated by suitable chemical methods. Can be separated into suitable chemical methods. This is first point, and this one second point, and this is third point. The properties of pure substances are entirely different from that of properties of pure substances are entirely different from that of the constituent elements. That means the properties of the compounds are entirely different from the properties of the constituent elements. Example, sodium chloride is a compound. So it contains the elements sodium and chlorine. The properties of sodium chloride is different from the properties of sodium and the properties of chlorine. So what are compounds? Compounds are the pure substances consisting of different atoms or different elements combined together in a definite proportion by mass. For example, sodium chloride is a compound. Here 23 gram of sodium combined with 35.5 gram of chlorine, forming 58.5 gram of sodium chloride. So compounds are the pure substances containing different elements. For example, sodium chloride is a pure compound consisting of two different elements, namely sodium and chlorine. Here this sodium and chlorine are combined together in a definite proportion by mass. Here 23 is the atomic mass of sodium, 35.5 is the atomic mass of chlorine. So they will combine in a definite proportion by mass to give the compound. This is first definition. Compounds are the pure substances containing different atoms or elements combined together in a definite proportion by mass. The components of pure substances, for example, sodium and chlorine are the components of pure substances. They cannot be separated by physical methods, but they can be separated by suitable chemical methods. When sodium chloride, molten sodium chloride is electrolyzed, we will get sodium and chlorine. So, these components in the pure substances cannot be separated by physical methods, but they can be separated or they can be decomposed using a suitable chemical methods. This is second point. Third point, the properties of pure substances are entirely different from the properties of its constituent elements. Properties of sodium chloride is entirely different from the properties of sodium and properties of chlorine. Similarly, this is sodium chloride. Number 2, water. Water is a compound. Water is a compound. It consists of the elements hydrogen and oxygen. Hydrogen and oxygen are combined in a definite proportion by mass. 2 gram of hydrogen combined with 16 gram of oxygen to form water. The properties of water are entirely different from hydrogen and oxygen. And then the components of water, namely hydrogen and oxygen, can be separated by cannot be separated by physical method. We cannot remove hydrogen and we cannot remove oxygen by physically, but they can be decomposed or they can be separated by electrolysis also. So, example, sodium chloride, water. Number 3, glucose. What is the formula of glucose? C6H12O6. So, glucose is formed by the combination of carbon, hydrogen, oxygen. These are the components of sucrose: carbon, hydrogen and oxygen. They are combined in this ratio: 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen in definite proportion by mass. These constituents cannot be separated by physical methods, but they can be separated into the constituents elements by any other chemical methods. So again, compounds are classified into 2 types, namely organic compounds and inorganic compounds. Write down. Compounds are classified into 2 types. Number 1, organic compounds, and number 2, inorganic compounds. So first we will know what is organic compounds. What are organic compounds? So organic compounds are obtained from living sources. Organic compounds are obtained from living sources, namely plants and animals. Nowadays, they are defined as organic compounds. The latest definition of organic compounds they are hydrocarbons and their derivatives. So example, urea, NH2CO NH2. Urea is obtained from urine. So it is of animal origin. Number 2, sucrose C12H22O11. Sucrose is obtained from cane sugar, etc. Urea, sucrose, acetic acid, citric acid, palmitic acid, etc. all are animal origin or plant origin, are the compounds of carbon and their hydrocarbons, means compounds of carbon and hydrogen and their derivatives. What is the another type of compounds? Inorganic compounds. Inorganic compounds. What are inorganic compounds? Inorganic compounds are obtained from non-living sources, namely rocks and minerals. So these are the inorganic compounds are the compounds which are obtained from non-living sources, namely rocks, minerals, etc. For example, iron is obtained from hematite ore, Fe2O3. So these are all the minerals. So during the manufacture of sodium hydroxide, we can manufacture sodium hydroxide by the electrolysis of sodium chloride, which is present in sea. So the products obtained from non-living sources are called inorganic compounds, sources, rocks, minerals, etc. Example, sodium hydroxide, sodium chloride, H2SO4. This is sodium chloride, H2SO4, sulfuric acid, etc. So this is how compounds are classified. So in chemical classification, materials are classified into two types. Number one, pure substances, and number 2, mixtures. Pure substances are classified into two types. Metals, pure substances are classified into two types. Number 1, elements and compounds. Elements are again classified into three types: metals, non-metals and metalloids. And then compounds. Compounds are the pure substances containing only one type of substances. So they are classified into two types: organic compounds and inorganic compounds. I told you what are organic compounds. Organic compounds are from living sources. Inorganic compounds are from non-living sources, etc. And now we will study what are mixtures. What is a mixture? So material containing different types of substances are called mixtures. material containing different types of substances, are called mixtures. Here the components are materials containing different types of substances. Here the are called mixtures. Here the components are present in different proportion by mass, then they can be separated by the components in the mixture can be separated easily by physical methods. So materials containing different types of substances are called mixtures. Here the components are present in different proportion by mass, are not present in a definite proportion by mass. They are present in different proportion by mass. Any amount of substance, one substance can be added into any amount of another substance. It forms a mixture. For example, when sodium chloride is added into water, so this is sodium chloride and this one is water. You can add any amount of sodium chloride and any amount of water, so you will get a solution. This is solution and it is called a mixture. So mixture is a material containing different types of substances. In any proportion by mass. Mixture is a substance containing different types of substances, or you can write in any proportion by mass. In any proportion by mass. So the constituents of the mixture, say for example water and sodium chloride, can be easily separated by physical methods. What is the meaning of this one? So sodium chloride present in water can be easily separated. How we can separate? By evaporation. By heating the solution of sodium chloride, water will be evaporated, leaving behind sodium chloride. So this is the method. We can easily separate the components of mixture. So these are the properties of mixtures. What is a mixture? Mixture is a material containing different types of substances in any proportion by mass. So the can be separated by any physical methods. Next, mixtures are of two types. Number one, homogeneous mixture, and number two, heterogeneous mixture. So I will tell you what is the difference between homogeneous mixture and heterogeneous mixture. What is a mixture? If you add one substance into another substance in any proportion, you will get a mixture. So these mixtures can be separated easily by physical methods. This is another property. Mixtures are of two types, homogeneous mixture and heterogeneous mixture. I will tell you what is a homogeneous mixture. Suppose so this is the test tube. I have taken water. What happens? So this is water. I will add sodium chloride. So this is water is one substance. Sodium chloride is, this is sodium chloride. Sodium chloride is another substance. So if I shake these two substances, what happens? So water is one substance or one component, sodium chloride is another substance or another component. When these two substances are mixed and shaken well, you will get a one layered substance. This is a single layer substance or single phased substance. These two substances mix together to form a single layer or single phase. Such a solution is called homogeneous mixture. Such a mixture is called homogeneous mixture. What is a homogeneous mixture? A mixture in which the components, the mixture in which all the components form a single phase. So all the components, what I have added, water is one component, sodium chloride is another component. These two components mix together to form a single phase or single layered mixture. Such a substance is called homogeneous mixture. Number two, the composition of this solution is uniform throughout. That means the concentration of sodium chloride in water is equally mixed in all the places. So the composition of sodium chloride is uniform. Such a mixture is known as homogeneous mixture. What is homogeneous mixture? A mixture in which all the components form a single phase and the composition is uniform throughout. And the composition is uniform throughout is called a homogeneous mixture. So first write down homogeneous mixture. Write down homogeneous mixture. Homogeneous mixture. So you will be asked, this is also important, what are homogeneous and heterogeneous mixture? Homogeneous mixture. Mixture in which all the components are present in a single phase, PHASE, are present in a single phase. This is a one phase system. That means one layer. There are no separate layers. There is only one layer. It is called single phase mixture in which all the components are present in a single phase, and the composition is uniform throughout, and the composition is uniform throughout. That means sodium chloride is equally distributed throughout the solution. That is known as uniform composition. Composition is uniform throughout is called a homogeneous mixture. Homogeneous mixture. Example for homogeneous mixture: number 1, mixture of water and sugar. Number 2, mixture of water and sodium chloride. Number 3, mixture of water and urea, etc. These are all homogeneous mixture. Homogeneous mixture. A mixture in which all the components are present in a single phase and the composition is uniform throughout is called homogeneous mixture. Mixture of water and sugar, mixture of sodium chloride and water, mixture of urea and water form a homogeneous mixture. So then what is heterogeneous mixture? So I will tell you, suppose this is water, it is one component. I will add another component, namely this is sand. This one is sand. What happens? So if I add sand to water, so this sand form one phase and water form another phase. So there are two phases in this solution or in this mixture. So look at here, this is sand and this one is water. When sand is added to water, we will get two layers or two phases. So a mixture in which all the components are not present in single phase, but they are present in number of phases. This is one phase and this one is another phase. Such a mixture is known as heterogeneous mixture. Here sand particles are not equally distributed throughout the solution. Sand form one phase, water form another phase. Therefore it is an heterogeneous mixture. So what is an heterogeneous mixture? Mixture in which all the components are not present in single phase. They are present in different phases. All the components are present in different phases and the composition is not uniform throughout. So sand particles will settle at the bottom and water is present at the top of the sand. So they form two layers and the composition is not uniform. Sand is not uniformly distributed throughout the solution. Therefore it is an example for heterogeneous mixture. Mixture of water and sand is a mixture. If you add sand and water, you will get a mixture. Here mixtures are of two types. If two components form a single phase, it forms a homogeneous mixture. If two components form two phases, it forms a heterogeneous mixture. In homogeneous mixture, the composition is uniform. In heterogeneous mixture, the composition is not uniform. So this is the main difference between homogeneous mixture and heterogeneous mixture. So now write down heterogeneous mixture. Heterogeneous mixture. write down, mixture in which all the components or all the substances which are present in the mixture are called components. Mixture in which all the components are not present in the same phase, are not present in the same phase, are present in different phases, in which all the components are present in different phases, and the composition is not uniform throughout, is called an heterogeneous mixture. Example, sand and water. Number 2, oil and water. So if you add oil into water, oil form one phase and water form another phase. So there are two phases in oil and water, therefore it is also an heterogeneous mixture. So, and the composition is also not uniform. Water form a separate layer and oil form a separate layer. They do not mix up, and such a system is known as heterogeneous mixture, oil and water, etc. So, this is enough for today. So, today we have studied chemical classification. In chemical classification, matters are classified into two types: pure substances and mixture. In pure substances there are two types: elements and compounds. In elements there are three types: metals, non-metals and metalloids. In compounds are the pure substances in which the elements which contain different elements combined together in a definite proportion by mass. These constituent substances cannot be separated by physical methods, they can be separated by chemical methods. The properties of compounds are different from the properties of constituent elements. And then coming to compounds are again classified into two types: organic compounds and inorganic compounds. Compounds from living sources are called organic compounds. Compounds from non-living sources are called inorganic compounds. Coming to mixture of two or more substances is called a mixture. If it forms a single layer and uniform concentration, it is called homogeneous mixture. If it forms different layers of different composition, it forms heterogeneous mixture. So, examples for homogeneous mixture: water and sugar, water and urea, water and sodium chloride, etc. forms homogeneous mixture. And then coming to heterogeneous mixture, for example, sand and water, sand and oil, water and oil, etc. forms heterogeneous mixtures. So, thank you very much.